to start the recording. I have some good news for you. Would you like some good news? Everyone likes good news, right? We have hit the threshold. 26 of you have completed a course evaluation. Way to go, team. So everybody gets 1 point extra credit for completing a university course evaluation. And if you've also completed your Qualtrics evaluation, then you get a 2nd point extra credit. So those will be added to your grades at the end of the semester once everything is in. So up to this point, I have caught up on, I believe, all grading and scoring. If you look at your point total and it looks like I'm missing something for you, let me know, and I will track down the source of the error or otherwise update. So I will be putting grades together Friday, like right after 5 o'clock, the deadline passes to get it done. So you'll be able to see where you ended up. But as far as I can tell, no one has any worries on that front because this class has been very diligent and I very much appreciate that. So it's our last day together. How's that feel? We made it. But not the last day with me, thankfully, because some of you are going to come back, right, and hang out in the fall. And we'll keep having the party, keeping the party started and going. Yes, hooray. And even if you don't want to come hang out with me in the fall, you have earned the right to bother me via email for the rest of your lives, pretty much. This is your right of privilege of being in this class. So let me know if I can ever be of use for you in the future in tackling these sorts of analyses, hopefully in your research lives and in the rest of your professional world. So we've got then just a few things to do today. I wanted to finish going through example 7b and just make sure that we hit the parts, the things that I wanted to emphasize that I haven't gotten to yet. We don't have to go into great detail. And then I had an activity in terms of story time. So on the website, I have a Word document posted with 4 example research designs and questions that I have encountered in the past, and I thought it might be useful for us to talk through them and think about how you would approach that type of problem given the skills that you've learned this semester. So let me let's see which one's going to be first. Let's do example 7b first. So I'm going to get that pulled up, get the screen share going. And I have, this is page 23 of 36. Move this thingy out of the way. Oh, I need to start the transcript thingy. Let me get that started, just 1 second. I knew there was something I was forgetting. There we go. Okay, can everybody see a giant set of equations? Yeah, then we're in the right place. Huzzah. So where we left off last time was looking at this model. So we had started with an unconditional model of random quadratic change over time. We're predicting response time as our outcome, so decreases across 6 sessions of practice. And the unconditional model, which is analogous to section 1 of your homework 5, is important because it's a baseline. So it tells you how much individual variation there is to be predicted in the intercepts for their predicted outcome at time 0, which should be the first occasion, and the linear slopes, which is also at time 0 given the quadratic term, and individual differences in the quadratic slopes as well. So there's 3 ways that people differ from each other. Therefore, there are 3 different ways that any level 2 time invariant person predictor can account for the individual differences. So each source of variance has a corresponding fixed effect. So we first had added age because in the context of this research, you have to control for age when you're doing cognitive aging research or someone's going to yell at you, even if it's not a hypothesized term. So we put age in the model, even though it only had a significant effect on the intercept. So the main effect of age at time 0 was significant. I am leaving in the model the interactions of age with linear and quadratic time. That way I can say that I have controlled for age with respect to each aspect of the growth curve, not just with respect to the intercept, but all of the trajectory that's created by this quadratic model. And so then I can add a predictor that would be an example of a more substantive predictor, such as the effect of meditation training in your homework, which is a grouping variable, And I added a note to the instructions. Let me I pull that up here. I have that as well. I added a note to the instructions for the homework. This is homework 5 that says, I would not recommend treating meditation group training as a categorical predictor, meaning don't put it on the class statement or make it IDOT or make it a factor variable. Just make a dummy code for it. Since it's coded 1, 2, you can just subtract 1, and then the control group is the 0, and the treatment group is the 1, and then it will look a lot more like the examples that we've been doing. So that's what I would recommend to make the code a little bit easier to do relative to the factor variable, which we have less practice with. So then you can think of group as like being where reasoning would be in here, where it's just the second predictor in each of the level 2 equations. So in adding gamma O2 right here, that is going to be the effective reasoning on the intercept. That looks like the main effective reasoning, so it would just be the variable entered into the model statements by itself. Gamma 1, 2 right here is the interaction of reasoning with linear time, and then gamma 2, 2 is the interaction of reasoning with quadratic time. So we're up to essentially a 3-way interaction in this model. So I had down here, I corrected all the typos that I found with respect to the fixed quadratic term in these simple slope equations and reposted the handout, so you should have the correct version available. How to get the simple slopes for any reasoning, any occasion, and any age for these models, and how to get the simple effects of age and reasoning for any occasion. So you can use this sort of pattern to be able to get predicted rates of change or simple slopes of your predictors at other values of the moderators besides 0. So in your homework, any question that's talking about something at time 0 is going to be a model parameter. Any homework that is, or anything that's talking about the control group is going to be a model parameter. So things where you're centered are most often going to be model parameters, and predictions that pertain to anything that's off the centering point is going to be a linear combination that you'd have to ask for. So just a little bit of help in diagnosing that. So we have then our baseline growth curve effects, the 3 effects of age, the 3 effects of reasoning, and a whole lot of code that demonstrates these simple slope computations given right here for different kinds of people. So we looked at most of that last time. And I wanted to focus on the results because I think we didn't get too far into that. So I'm on page 26. Okay, with me so far? Yes. Any questions or things you want to talk about before we dive back in? Okay. So then the pattern of what has happened here, this term right here, the main effect of reasoning, what does that tell me? I have a coefficient of -27. It does have a p-value of less than 0.05. What is that telling me? I'm eagerly waiting the chat window. Or you can talk. I know that's old-fashioned, but you can talk. Nobody knows what this is telling you? Nobody wants to say.
So as reasoning score goes up by 1, the reaction time drops by 27 seconds?
Yes, and add one more clause at the end of that, because it's conditional.
At time 0?
There you go, at time 0, exactly. Everyone is saturated. Yes, that may be true, but it's only 2:13 and I can't throw in the towel yet. Although, to be fair, I did let my other class go early, so there's a chance that that could happen too. See, think of it this way. The sooner somebody coughs up an answer, the sooner we could potentially leave early. So if you're thinking to yourself, I don't want to be the person who answers all the questions, you have my permission to be that person today. And I'm sure your classmates would not object to you being that person today either. But yes, thank you. This is the effective reasoning on the intercept specifically. And because of these interaction terms, it is at time 0. So people who are stronger in reasoning start off with a lower response time, so they're faster. And then the effective reasoning on the linear slope, what's happening there? This is a pattern of a more negative interaction. What's it doing to it? More negative, yes. So people who have stronger reasoning as measured by this predictor ... do what? Learn faster? Get faster? Yeah. More downer. More downer means they are improving faster at response time. Is that sufficient, or do I have to keep talking and add a conditionality to the end of the sentence? People with higher reasoning improve at a faster rate. Yeah. What's it conditional on? Time 0, ding ding. Yeah, because of this three-way interaction term, this two-way interaction is conditional on time 0. So back to the instantaneous linear rate of change. See, this is your tuition dollars at work, that you get to see this awesome visual that none of the YouTubers get to see. My stick changing slope as we go down the curve here. So age by reasoning at time 0 is the age by time term. And that's because the effective reasoning on linear change changes. It becomes reduced. And so this is the point where you're like, yeah, no, does not compute. And you say, can I please have a picture? And I say yes. So this is what the model is telling us, visualized with time on the x-axis and different lines for different values of the level 2 predictor. This plot was created in Excel for pedagogical purposes, holding age constant at 0. So this is for an 85-year-old or 80-year-old in this class? I've already lost it. 80? 80 in this class. It was 85 in the other class. So similar stories in this case. So the top line is for somebody with low reasoning ability. They start out the slowest. Then we have the middle line, which is the reference growth curve that's given by the fixed linear and quadratic slopes for time. They are conditional on somebody with reasoning 22. So this is, middle line is illustrating sort of the reference curve. And then people who with higher reasoning are down here. So as reasoning goes up, meaning as you change from the top line to the bottom line, we start out faster and initially change more, but then there's a greater rate of deceleration. So it looks like there is a bigger effective reasoning at the beginning of the study than there is at the end of the study based on this curve. So you can think of it either way, as how reasoning changes the growth curve or how the effective reasoning changes across time. Now, however, the purist among you might be saying, but Lisa, these interaction terms aren't significant. And I would say, yes, you are correct. So here's a question. If reasoning doesn't have any special status, it's not a covariate that I have to include or I'll get yelled at. If it's just, something I could include or could not include, What do you think I should do about this? Do you think it's okay if I take out these non-significant interaction terms? Because they don't contribute to the model? That seems like a reasonable thing. If I don't have a predictor that someone is going to insist I keep in the model, then it's up to me what I do with it. So I could take these out because these interaction terms are non-significant. That means they're not improving my prediction. They're just soaking up degrees of freedom, etc. But here's a question. Should I dump them both or go one at a time? Got one vote for one at a time. Another vote for one at a time. Yes, I'm going to vote for one at a time. Which one goes out first? Quad. Yeah, see, I should threaten to end class early every day. I'm getting great rates of participation. Lesson learned. Yeah, we're going to take out the three-way interaction. I want to show you side by side what happens when we have it in versus when we don't have it in. So I'm going to open up a new window and put it down below. So yeah, I'm going to dump that three-way interaction term that's not significant. And I'm going to estimate a new model. So we have this revised model where, do you see where the hole is right here? That's where the three-way interaction used to be. So note that this is one of the things that I tend to do when I'm writing equations. I have deliberately spaced over U2, like I left the space open, because I think it makes the point as to what could be there that isn't there. I also would omit gamma 22 as the number that could go here. Like if I added another term, it would become 2, 3, because I'm leaving this spot open to demonstrate that this effect is not here. And so after I do that, here's what happens. And this is where I wanted the side-by-side comparison. Nope, I don't want that window. I want this one. Almost. There we go. No. Come on, dude. There we go. Got it. Okay. So main effective reasoning was minus 27 before. It was significantly negative. Is now minus 32. Still significantly negative. Nothing changes. The interaction of time by reasoning was non-significantly negative, but it was conditional at time 0. Now look what happened down here. Different result. Can I just highlight them both at the same time? No, I cannot. So I'm comparing time by reasoning from the prior model that included the three-way interaction to time by reasoning from this revised model without it. Now it's significant. Now, why might that happen? Do you remember learning about, it's always phrased as either collinearity or multi-collinearity in regression? The supposed danger that's not really a thing. It just means that if you have predictors that are related to each other, it's more difficult to ascertain what their unique effects should be, and their standard errors are going to be larger because they have less unique variance. Remember that? So do you think that age by time is going to be related to age by time squared? Yeah, odds are good. So the result is different without the three-way interaction for a couple of reasons. Number one, You're eliminating that predictor that is constraining how much unique variance that age by time has to contribute, but you're also changing the interpretation of the coefficient. So up above time by reasoning, the coefficient of minus 3.6, that is how age changes the linear slope specifically at time 0, at the top of the curve. The bottom result, time by reasoning, is the highest order term. So the bottom result is how age changes the linear slope on average across time. So they refer to two different things. And I have a revised picture then for what that looks like. So the new model that eliminated the three-way interaction, the quadratic aspect of these curves is the same. The main effective age is still there, and age by linear time means that people who are smarter have it's the direction of it changed, that's right. Yep. Now there is a less steep rate of change in people who are smarter. So people who are smarter start out lower and they change less rapidly. And that's across the whole thing. So the point of this story is when you're dealing with quadratic models, terms that are related to linear time and time squared as quadratic terms, they have a lot in common. Be very careful in dumping both of them at a time. So if you're looking at a complex model that has non-significant interactions, I would drop them one at a time just to make sure the story doesn't change because of the relationship between these predictors and because of the conditionality at time 0 in the presence of a higher order interaction. So that was my point. Seem reasonable? Yeah, I think so. All right, and then the last model is education group, and it looks a lot like the piecewise model, and there's no effective education, but I just wanted to make the point that when you're adding group as a predictor, you are adding in as many dummy codes as it takes to distinguish the groups. So in this case, if I have 3 groups, each fixed effect is actually 2 different terms. The fixed effect of education group on the intercept is 2, on the linear time slope is 2, and on the quadratic time slope is 2 as well. So keep that in mind that for categorical predictors, it doesn't look like you're adding a bunch of terms if you treat them as factor variables, but you actually are. So I wanted you to have an example of that. And as I stated last time, nobody needs to be jotting down everything I say because at the end of this handout, there are words. So how I would talk about all of these results, putting it together as a demonstration. So question, is this also a Jenga game? Yes, kinda. Except in Jenga, you can take out the terms in the middle. Here you want to like take out the bottom layer or the top layer, I guess. The top layer would be like the highest order of the model, so I think you take the pieces off of the top. But that's one way of looking at it. Okay. So any questions on that handout or as it relates to homework 5? Okay, do you want to do story time? Yeah, maybe? Okay. So here are the stories that we're talking about. And the first story has to do with a student from University of Nebraska-Lincoln who is now an associate professor. She studies children with speech issues. And she had a class project that we tried to publish. But before we could publish it, we had to figure out how to make it into a model. So here's the background for her story. She's had data collected from, I would go with infants to toddlers in the complexity of their speech. And so the outcome that she was studying was a variable called consonant to vowel ratio. Basically, how many consonants are in their speech relative to vowels. And at 9 months, there's no consonants. They're all just like, eh. Like if you've ever listened to children talk, it's just, and then eventually they get some words and they say things like, damn it, and other things you don't want them to say by the time they're 3. So she was looking at growth over time in the extent to which they're using consonants, essentially. And what she wanted to do with that is to predict subsequent reading performance. So letter identification as sort of a pre-reading ability at 72 months, which is, I believe, 6 years old to the rest of us. Had to do the math there. So Shinji, are you here? You were asking me a question about this. Yes, I see your box.
Yes.
Yes, this
Yes,
one's
I'm
for
here.
you, Shinji. So her outcome, because it was measured when they were 6 years old, was their skills with these pre-reading letter identification things. And she wanted to know how growth in their speech predicted their later cross-sectional outcome. So what do you think about fitting a model like this in Mixed or in Elmer, one of the packages that we've done this semester? How would that work? Any ideas? The last point is time 0. Well, she has a growth curve of what is, functionally speaking to her, a predictor. Children's growth rates in their speech predict an outcome measured at one point in time that is a different variable. That's what she wanted to know. So I'm picking on Shinji because he asked me a question a couple weeks ago that was very similar in structure. And do you remember what I told you, Shinji?
Yeah, you told me actually at least start mixed cannot take the level 2 or like a between person outcome variable.
That is
But
correct.
SEM can do that. I don't know how to do that.
Yeah, the answer is yeah, you can't do that. Multi-level models are for level 1 outcomes. The way she's thinking about it, she has a level 2 outcome that is measured once per person. So the answer isn't you can't do this, but simply that you can't do it this way in Mixed. So she had 2 alternatives. The alternative that Shinji mentioned is to turn this into a structural equation model. So do you remember like 2 months ago when I was talking about how random effects and latent variables are the same thing? And I showed some SEM diagrams about how you would fit growth models in an SEM framework. If you haven't had SEM from me and you've blocked out that painful memory, no worries. Just know that it can be done. And one of the benefits of using SEM instead of Mixed is that then you can have your growth curve random effect latent circle thingies be predictors of something else. Yes, thingy is a technical term. So in SEM diagramming imagery, you'd have like a box on the right hand side, and you'd have your intercept and linear growth circles predicting the box. And so that's one option. However, if she uses SEM software, then she has to use maximum likelihood, or I suppose Bayesian estimation, but this conversation happened in like 2008, so that was less of a thing back then. And what is true about the use of maximum likelihood estimation as opposed to residual maximum likelihood, which is what we've been using? Do you remember that? Homework 2, I believe. What happens if you use maximum likelihood instead of residual maximum likelihood for these models? Something is inflated, yes. Takes into account the number of fixed effects, Remel does, ML does not. Too small sample, yes, all of those things. So in maximum likelihood, the variances that you get for your random effects are going to be too small in small level 2 samples. That translates into greater type 1 errors for the corresponding fixed effects that go with those random effects. And the difference between what you would get from ML and Remel starts to sort of asymptote off somewhere between 50 and 100 people at your sample size. And so I will remind you, the sample size that she was dealing with was 12 people. And further, only I think 8 of them had the 72-month reading outcome. So do you think it is advisable to estimate a structural equation model with 8 people? Probably not. So she stuck with the MLM framework, I think, for this. So what I ended up telling her to do is to treat the 72-month reading outcome as a level 2 predictor. Because here's my rationale. If X predicts Y, then Y also predicts X. And then she's like, but isn't that weird to have something in the future as a predictor of the past? And I said, yes, but think of it as foreshadowing. Do children who eventually become better readers, is there evidence of that in their infant profile? If you pitch it that way, it makes sense. So that is what I ended up having her do, is to treat that as a time invariant predictor. And we got feedback about the methodology from people who were really wanting to contribute, except that they didn't quite know what they were talking about by evidence of their questions. So one reviewer comment was, I really think that you should check your G matrix to see if it needs to be autoregressive. So do you remember what G stands for in these models? G is the level 2 matrix of random effects, variances, and covariances. Now, what if I further told you that, perhaps in part because she only has 8 children, none of the random slope variances, she ended up with a quadratic growth trajectory, none of the slope variances were significant. Only she had a random intercept. So Kelly says, I didn't think G could do that. It can technically, in the sense that SAS allows it. But does that make any sense to ask the question whether your random effect variances and covariances have an autoregressive pattern? No. And if I further told you that not only does that not make sense, but we only had a random intercept variance in G. Can one number have a pattern? No. So my spin to help respond to this was, I think the reviewer meant the R matrix instead. And they have a point. Can the R matrix plausibly have an autoregressive pattern? Yeah, R matrix is your level 1 residuals. Particularly if you only have a random intercept. A random intercept implies a constant correlation across your occasions. So it's possible that occasions that are closer together in time, that their residuals would have an extra correlation component. That's a reasonable thing. So we tested it, it didn't make a difference, and that went into the response letter. Another reviewer looked at our sample size and said, you can't do multi-level modeling with 8 people. And my response, of course, was tempted to be something like, I just did. But that wasn't going to fly. So I pointed out that we used residual maximum likelihood and we had only a random intercept in the model. So functionally speaking, what kind of model do I have with only a random intercept and residual maximum likelihood estimation? It starts with an R. Repeated measures ANOVA, ding. That's what I did. I did an ANOVA. So if you were going to be okay with the repeated measures ANOVA, you have to be okay with this model too. The only difference is that repeated measures ANOVA would have required list-wise deletion of anybody who was missing any occasions, and this way we at least got to keep some in. And this eventually did get published in a Frontiers journal. So the moral of the story is perseverance. So, thoughts or questions on that? I have another handout, by the way, that has the model and SAS code that goes with the end of the story that I'll post after class so that you can have that for your reference. Story number 2. This is a former graduate student in developmental psychology who is now working at the University of Kansas, and this was her master's thesis. And their lab was looking at the effects of tobacco exposure in utero on subsequent childhood outcomes. So they had a sample of mothers who admitted that they smoked during pregnancy and a sample of mothers who claimed they did not smoke during pregnancy. And I'm framing it that way because people lie. But that's what they said. And they have little boys and little girls, and they gave them a task that measures delay of gratification. So are you familiar with like the marshmallow experiments for this genre? Yeah, where you put a couple marshmallows in front of a kid at a table and you say, I'm going to leave for a few minutes, and if you cannot eat those marshmallows, you get to eat both of them. But if you eat the snack, then you don't get some other reward, right? And so they measure how long it takes before the child caves and eats something. And also they measured how well they were able to sit still. And so they were able to delay gratification more over time. So this axis is more movement. So they were able to hold more still and delay gratification in this outcome. And this is a plot of linear versus saturated means. Looks like a linear trend works pretty well to describe change over time. And so what they wanted to know is, first off, what is the effect of tobacco exposure on change over time? And to what extent might there be gender differences in the effect of tobacco exposure? So what might this look like? Interaction with gender? Interaction with what in gender? Tobacco smoking? So if I entered in main effects, let's say, and an interaction term between tobacco status and gender, that would get me differences in mean level. Intercept differences.
Sorry, what's the yellow, the red and the black lines again?
I'm trying to look here. The black line, it looks like, is saturated means, and the red line is the fit of a linear model.
Ah.
So on average, it looks like a linear effective time describes this rate of change. So we have thinking of gender as a level 2 random intercept. Gender as a level 2 predictor, which could be a predictor of the random intercept. Yes, indeed. But if the question is about the effect of tobacco exposure on growth and gender differences in that effect, what am I missing? Slope, which one? Yeah. This is a three-way interaction hypothesis, friends. And all this time you thought I was torturing you with estimate statements just to be mean? It turns out that interactions actually do answer research questions a vast majority of the time. So yes, this is a three-way interaction question, because we would have smoking by time, which would answer the question whether children who are exposed to tobacco have different rates of change than children who are not. And then smoking by time by gender would then add whether or not boys have a different effect of tobacco exposure on growth than girls do. And it turns out there was a difference. I don't remember which way it went, but I do not believe this paper was ever published because the reviewers did not think it was novel enough. And the other part of it was that after controlling for SES, some of the main effects went away, because SES is correlated with smoking in this sample and in a lot of samples. Yeah, so that was the kicker. So. But she did graduate, so there is a happy ending there. She wrote it up, turned it in, got her master's degree, eventually wrote up a dissertation, turned that in, and got her PhD. This is a story that requires another figure. Story number 3 here. This is a depiction of what is known as a waitlist control design, where you're trying out the effect of a treatment on people in a circumstance in which it would be unethical or ill-advised to have a control group that doesn't get any treatment. So the solution to it is to delay the control group and eventually give them the treatment, just not at the same time. So ideally, if you are trying to improve an outcome, such as mental health outcomes, in which higher scores mean more functioning profiles, if you had a treatment group as illustrated by the green line, you would want them to improve relative from baseline after treatment, and then if you don't do anything further to them, optimally, you would expect them not to change any further and to just be fixed. So that idea of improvement from baseline after treatment and then maintenance is illustrated by this green line prediction. Meanwhile, the waitlist control group doesn't have anything happen to them between time 1 and time 2. They get their treatment after time 2, and then they get fixed and they've improved by time 3. So waitlist control design with only 3 occasions. There were 24 people in total at the beginning of the study, and it was down to 12 people by the end. So a big problem with missing data, and likely not randomly missing data. And the research question, quite simply, does treatment work? How would I approach something like this? What if I put in a linear effective time, a main effective group, and an interaction between linear time and group? Would that do it? Can I repeat that? Yes, I can. So a common way to think about whether there are group differences in change, which is the idea of whether treatment works, would be whether people improve more after they've been treated. What if I put in just a linear effective time between occasions 1, 2, and 3? I put in a main effective group, and I put in a group by time interaction. Would that work?
It doesn't take into account the change in conditions between treatment and control.
It doesn't, and because time is not linear here. If you see elbows, right, in your plot, like a linear slope is not going to work. But yes, we have a suggestion for a piecewise model. Ding, ding, ding. So we would have multiple opportunities within a piecewise model to answer the question as to whether treatment works. Yeah, so I could compare the slope of the first green line to the slope of the red line, because the red line describes what would happen if you just left them alone, and the green line describes what happens after treatment. In the red group, because of the design, I could describe whether treatment works as the difference between the slope from 1 to 2 versus the slope from 2 to 3. That would be a within subjects comparison. And to get a sense of the stability of the treatment effect, I could compare the slope from 1 to 2 for the green group with the slope from 2 to 3 for the red group. And if treatment works equally well across cohorts, those slopes should be the same. So if I did a piecewise model, let's say that I used wave 1 as my intercept. I have 2 slopes. I would put in a group difference and group by each of the slopes. That would fully saturate all 6 possible means here. So that would be 2 slopes for the green group, a main effective group, and then 2 interactions for the red group, or vice versa. That would give me the 6 means perfectly well. Okay, with me so far? If I did that? So that's what I asked the student to do. And unsurprisingly, there was no evidence of random slopes. And with only 3 occasions, only one of the 2 slopes could be random anyway. So I had her compare 3 different models for the variance. An unstructured model is the right answer. A compound symmetry heterogeneous model, which would be different variances at each occasion but the same pattern of correlation. And a compound symmetry model, which would be equal variance, equal covariance. And compound symmetry fit not worse than the other 2, so that's what she went with. So the results, sadly, suggested that treatment did not improve. She didn't have significant effects. And so then she wanted to turn to time-varying predictors and look at how those might have changed things, and sadly, those were non-significant. And so then she's back in my office saying, my advisor told me that he thinks that I should just do repeated measures ANOVA and not try to do all this fancy multi-level modeling. You're shaking your head, but this is a true story. Names have been omitted to protect the guilty. Would anyone like to do an impression of me answering the student's question? So the comment was, we don't need this fancy multi-level modeling, not coincidentally because none of the results are significant. Let's just go back to repeated measures ANOVA. It isn't even fancy. I know. It could get much fancier. That wasn't my answer though. I will remind you of this, what she ended up with. A model in which the 3 means for each occasion are perfectly predicted. So it's like a 2 by 3 group by time and a random intercept. What does she have? Okay, I'll do my own imitation. This is an actual reenactment. My advisor thinks I need to do repeated measures ANOVA instead of this fancy multi-level model. My response? It is repeated measures ANOVA! Bah! Something like that. Yeah, basically. Because this was like the 7,000th conversation I've had with this student. And after I've painstakingly guided them through all of this process to be told that what I'm doing is incorrect and that I need to do the same thing under a different name, caused me to have a reaction. So I may have thrown a fit, but then I'm like, look, what would happen to your data if you put this into a repeated measures ANOVA that uses ordinary least squares instead of residual maximum likelihood, what would happen to her sample? You'd lose half of it. So this, functionally speaking, what she ended up with is a repeated measures ANOVA with respect to the model for the means and the model for the variance, but it's using maximum likelihood so that she can use all available occasions, and so that she can look at time varying predictors, which are not a thing in repeated measures ANOVA. And I do not know what happened as an outcome because I was not on this committee. So I know she graduated. So she made somebody happy enough. Last story. A real world problem. So this was a participant in one of my workshops that I used to teach in the summertime on longitudinal models. And this is somebody from a public policy kind of place. And they were looking at a sample of homes that had been designated in some cases as needing remediation for mold. So they had a data set of property values that they were looking at, and some of the houses had been chosen for remediation and some of them had not. And they were tracking home prices in a particular area of town for 18 years. And there was a public meeting about this problem, sort of announcing this plan for remediation in year 6. And then they did all of these assessments. And then in year 14, the houses that were bad enough were started being remediated. And this is a plot loosely of the two means of these two types of houses. And the question was, did remediation hurt property values? So this is not just a research exercise. This person was going to testify in a courtroom because there was a lawsuit from some of the people whose homes were chosen for remediation because they believed that it brought down their property values. So what do you think? How would you try to provide evidence either for or against this idea that remediation is related to lower property values?
Can you explain again what happened at year 6?
In year 6, there started to be publicity about this problem. There were like town hall meetings and things letting people know that this was coming and that their homes were going to start to be evaluated. And in year 14, the homes that were selected for remediation started actually getting worked on. And these are home prices, sort of like not necessarily sales, but sort of like projected home prices based on various sources of data across the 18 years. That's what the y-axis is. So if I have 3 distinct segments of time, before this became public knowledge, after, and then after cleanup started. Any ideas? Yeah, this is piecewise. That's what I suggested. So this is an instance in which you could potentially fit not only distinct slopes through each period, but also what I call jumps, shifts, and intercept. Now, based on this picture, it doesn't look like remediation hurt the houses because it looks like the houses that were selected for treatment were already of a lower value to begin with. But at least you could find a way to operationalize whether or not houses sold differentially for less value after these different points in time. Other things that are not in the story here that I think would be relevant is in deciding how much to offer a house, you're looking at the features of the house, like the square footage, the number of bathrooms, the number of bedrooms, number of garages, stuff like that. Another way that you can think about this process hurting home values would be if you don't get as much bang for your buck, like if the effect on home price per square foot is different between remediated and unremediated houses. So that would be a level 2 interaction potentially, where we would have the square footage of the house as an interaction with treatment status. And you could see whether houses that were treated have a smaller increase in home value per square foot, something like that. So there's a lot of ways to approach it, but I think in this case, the piecewise models is a natural extension of how I would approach the problem. Because you can look at whether or not the growth in home prices was equivalent or different during each of these segments of time across different types of houses. And you'd want to try and control for all the reasons why some houses are more expensive than others that have nothing to do with remediation.
How do you compare when the pattern is different in different segments? Like it looks linear in the third and it looks maybe quadratic in the second.
Then you can fit whatever pattern you want in each epoch. You could do linear in the first, linear plus quadratic in the second, and then it looks like straight linear in the third. And then you would have potentially red versus green here as a moderator within each section of each aspect of the trajectory. So yeah.
Can you compare across sections when they're different patterns?
You can. So like you could compare the linear slopes between phases 1 and phases 3. In order to compare the linear slopes from either phase 1 or 3 to phase 2, you'd have to pick where you want the linear slope at, right? So if it's a quadratic model, then it's like, which linear slope are you talking about? And then that gives a little bit more, I guess, ambiguity in that sense that it could be any of them, but you could do it at each specific occasion and just make a list of them. So then all your estimate statement skills would come in handy. So yeah.
Because it looks like the rate of growth increases after the treatment.
Mm-hmm. It does look like it, although given that there's really no control condition here, I don't know what the rate of growth would look like in like a different neighborhood that didn't have any of this happen. Whether or not, like, this was 2008 where they were at the lowest versus, later on where home prices, because home prices fluctuate with all kinds of other things too. So this would be a case where you'd have to pick your control variables very carefully to make sure that you've isolated what they're really talking about. And I don't know what happened, other than that the person went back to wherever they came from and they were pursuing this as a line of research. So. Okay, it's 3 o'clock. I promised that if you answered my questions, I'd let you go early, and I am a person who keeps their promises. But before I let you go early, I want to give a very sincere thank you. I'll put this back so you can all see each other one more time. I want to thank each of you for showing up, for continually keeping in here, fighting through the estimate statements and everything else that I threw at you, and trying your best in what is a very challenging year. Thank you very much for your efforts. Let me know if I can ever help you in the future, and I really hope to see most of you again. If not, enjoy your summers, be productive, be happy, and be safe. Thank you, everyone. Signing off for the last time.
Thank you.